series, summation 1 upon ln. So I'm giving you today almost 1 minute to think, and if you say yes, then I will proceed. Okay, if you say C, I mean convergence, and if you say D means divergence. So what do you think about this particular series? Okay, so let us start with this. Okay, let us start with this, and don't think that it is not going to come in exam. It is going to come in exam. At least in TFR you can expect all these questions. Okay, chalo. So let us begin. Understand that whenever you have a series, you what is something that you can use? You can use ratio test, you can use root test, but again you see taking a ratio would be a difficult thing here. Okay, so better why not use the comparison test? Why not use the, so let us use the comparison test. And I'm going to reiterate it. I'm going to reiterate. If you are not actually, if you have not revised, let me reiterate that if you have this summation an and if you have summation bn, these are two series, and such that an is less than equal to bn. If bn is convergent, then an is convergent, and if an is divergent, then bn is divergent. So if an is divergent, then bn is divergent, and if bn is convergent, then an is convergent. Okay, now let us make a little bit of graph so that you will be able to follow it. See, this is your x, this is how your y is equal to x, that is a linear graph, and this is how your graph y equals to ln x behaves. So how would your graph y equal to ln x behaves? This is how your graph y is equal to ln x behaves. Okay, so clearly you can see, at least for all positive, overall you know that always you can see that ln x is always less than x only. So what is x here? X belongs to all x greater than 0, but in general here we are using natural numbers, so natural numbers fall in this category only. So let us replace x by n. So if I replace x by n, then I can say that for all n greater than equals to 2, why 2? Because if n equal to 1, then ln1 is 0, and 1 upon 0 you cannot define. So for all n greater than equals to 2, I can write that my ln n is less than n, and if I divide it, like if I take a reciprocal, so this will be it. Now since summation 1 upon n is divergent, summation 1 upon n is divergent, it implies what? It implies summation 1 upon ln n is also divergent. Summation 1 upon ln n is divergent. Please let me know in the comment section, have you got the thing or not got the thing? If you have not got the thing, I'll revise it for you. If you've got the thing, I'll move to the next problem. So we'll keep it dynamic. Okay. Okay, so just let me know if you've got this particular thing. Okay, so now let us do another problem. Okay, so try to do this problem. What do you think about this series? Summation n equals to 1 to n equals to infinity, 1 upon n square minus of n. What do you think would be answer to this? What do you think, whether it will be a convergent series or a divergent series? So let us do it. So if you remember, we did in the very first class something called as telescopic series. Yes. So if you want to write in this fashion also, then also you can do another way also, I'll teach you. So let us write this particular thing in this fashion. I think it should be n equal to 2. So n equals to 2 to infinite, 1 upon n minus, sorry, 1 upon n minus 1 here, and I can write n here. Okay, so this will give you this only. Okay, this is I think very easy to see. This will give you 1 minus 1 by 2 plus 1 by 2 minus 1 by 3 plus 1 by 3 minus 1 by 4 plus dash 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 1. If you take one more bracket, 1 minus n minus 2 minus 1 minus n minus 1 and plus 1 upon n minus 1 minus 1 upon n. Now this is the telescopic series, and you can see that in each of the bracket, the latter part is being cut by the next bracket's former part. In each of the bracket, the latter part is being cut by the next bracket's former part. In each of the bracket, the latter part is being cut by the former part. In each of the bracket, the latter part is being cut by the former part. Okay. Similarly, this will be cut. Oh, sorry. This will be cut, but this is a latter part whose former is not here. Whose former is not here. So what you'll get? You'll get that this particular series is equivalent to what? Writing. It is equivalent to writing 1 minus of 1 upon n and limit n tends to infinity. So clearly this series is convergent and it converges precisely to 1. So this series is convergent. So this is something that I have done. This treatment I have taught you in series called as telescopic series, if you remember. Is that clear? Should I move? Acha. One more way I could have proven this. So if someone asks you how to do it using comparison test, obviously by comparison test I cannot tell what is the sum, but I can tell regarding convergence and divergence. So what do you think about convergence using comparison test? So using comparison test, if I have to think about this particular series, what can I do? So I can write 1 upon n square minus n clearly is less than 1 upon n square. Why? See, okay, this would be not greater than. Okay, so that will not. So instead, if I give you this problem, okay, so it will not be able to. Will not be able to pursue it. So better we'll do another problem, and then I think you can. Now you just tell me another telescopic series I'm giving you, and you don't have to do it using comparison test, because you see in comparison test, whenever you are applying comparison test, remember with which series you are comparing. If the series here is convergent, then you can say anything about this series. If the series here is divergent, then you cannot say anything about this. So that is a problem. Now let us do another series, the same telescopic series. Now try to do this using comparison test, whether this will be a convergent series or not. So indeed this will be a convergent series. Why this would be a convergent series? You can use the telescopic series that I used, and if you don't want to use it, I can actually write it in this fashion. This is n square plus n. Obviously this will be less than 1 upon n, because here you are 1 upon n square, because here you are dividing by n square plus something. So basically the denominator is heavy on this side. If denominator is large, so I can say that this particular portion will be less than this particular portion. Now since summation 1 upon n square is convergent, it implies summation 1 upon n into n plus 1 is convergent. Summation 1 upon n into n plus 1 is convergent. You could have done this using this comparison test, telescopic series treatment also, and otherwise also. Just let me know if this thing you've got. If you've got, then I'll move further. What do you think about this series? What do you think about this series? Please let me know. What do you think about this series? Okay, so what do you think about this series? So here in this particular series, it will be fruitful for you to use the D'Alembert ratio test. Why? See, because here it's easy to find the limit. Okay, if I replace by n plus 1 factorial, if I replace n by n plus 1 factorial and here by n plus 1, and then things would be easy. So what did I tell you yesterday? That if you have a series summation an, and you have to think about convergence and divergence, and if I say that limit n tends to infinity, an plus 1 divided by an is equal to some limit, let's say r, and if this is less than 1, then we can say that summation an is convergent. Then we can say that summation an is convergent. Then I can say that summation n is convergent. Now let us do this particular exercise. Let us do this particular thing as an exercise for D'Alembert ratio test. So what is an here? So an is n factorial divided by 10 raised to power n. So an is nothing but n factorial divided by 10 raised to power n. Now if I do this, what does it imply? If I do an plus 1, so an plus 1 would give me n plus 1 factorial. Just give it a minute. Okay, so n plus 1 factorial divided by, here you have this 10 ki power of n plus 1, and here you will get 10 ki power n, and here you will get n factorial, right? So eventually this particular thing, it will yield you, sorry, an plus 1 upon an. So limit n tends to infinity, we have to explain, we have to write an plus 1 upon n, right? I hope this is clear. I don't think there is an issue with this. I think this is quite easy to see that this limit will come out as n plus 1 divided by 10, and this will go towards infinity. So clearly, if r is less than 1, then this is convergent. If r is greater than 1, then this is divergent. And if r equals to 1, then this becomes inconclusive. So clearly you can see that the limit is infinitely large. Limit is infinitely large. So therefore, this series will be divergent. This series will be divergent series. This series will be a divergent series. I hope everybody has got the point. Okay, now try to do this question, which I'm giving it to you. I think this would be an easy question for you. Try this. What can you say about this series? I mean, what can you say about the convergence and divergence of this series? Summation n equals to 0 to infinite 1 upon 2n plus 1. What can you say about this series? So what I'll do, I'll use something called as limit comparison test. Okay, I can use something called as limit comparison test, or also I can use something else, like I can use comparison test also. Like for example, if I want to use comparison test, I'll use comparison test here once, so that you will be able to understand the comparison test. See, on comparison you can clearly see that n will be less than 2n. Clear? For all n belongs to natural, I can say that, okay, in that particular case n will come here, right? So no comparison test nahi. So I'll not use comparison test, I will use limit comparison test. It's better to use limit comparison test. It's better to use limit comparison test. So I know that 1 upon n is a divergent series, right? I know that 1 upon n is a divergent series. Yesterday I told you that if I take two series an and bn, and if I take the limit of it, so if you remember, then good. If you don't remember, let me show you. This is what you mean by limit comparison test. Yesterday we did it now. So this is called, I'm going to use something called as limit comparison test. See, whenever you cannot think of any series for comparison, what you can do instead, if you know some series whose behavior you know. So for example, then all you need to do is that an by bn you have to take, and if it converges to a finite limit n tends to infinity, an upon bn is some finite positive limit, then an and bn both converge or diverge together. So an and bn, summation an and summation bn both converge as well as diverge together. Okay, so this is something that you should remember. Now you see, if I want to use the same test here, how should I do it? So just let me know. So if I have to use it here, so I know here there is a linear power in n. So I'm giving you summation 1 upon 2n plus 1, right? So and what I can do, I can compare it by 1 upon n. So what I'll do, this is my an and this is my bn. This is my an and this is my bn. So it will be 1 upon 2n plus 1 divided by 1 upon n limit n tends to infinity. You will get n upon 2n plus 1, and this is n tends to infinity. And if I take an n common out from here, if I take an n common out from here, this would be 1. And n here also, if I take common out 1 by 2, which is certainly a non-zero limit, it implies summation an and summation bn behave the same way. And I know what? I know that summation 1 upon n is divergent, same way. I know that summation 1 upon n is divergent. Since summation 1 upon n is divergent, it implies what? It implies summation 1 upon 2n plus 1 is also divergent. I hope it is clear. Okay, I hope it is clear. So just do a few more questions so that I mean, why I'm making you do all these questions, because so that at least in exam you should be quite aware that when to use what. Otherwise, we'll get confused there. What can you say about this? Therefore, today is the last turn for this particular topic. Probably from tomorrow we are going to start with power series. Okay, so there also questions regarding radius of convergence is being asked in exam. So Taylor series we are going to discuss tomorrow. But today this is the last one for the infinite series. Okay, just try to do this question. What do you think about this particular? What do you think about this particular? What you can say? What do you think about this particular series? What do you think about this particular series? Okay, what do you think? And all these questions are from I think ARFCAN only. Okay, so you may expect these questions to be repeated as it is in your exam. What do you think about the series? I'm giving you 2 minutes to think about it, and then I will do it. If you're not able to do in 2 minutes, then I will do it. Don't worry. So, what do you think about this particular series? Any idea? Or should I do it? See, I'll do it for you, don't worry. So basically what is happening, see, here you have this thing. Here you have n into n plus 1. So what I can do, just think about this. What it is equivalent to? It is equivalent to n square plus n. Okay, this is equal to n square plus n. And it will be less than, so if I'm multiplying n, sorry, what I can say, this is n square plus n is nothing but it is equal to n into n plus 1, right? So if I am doing n into n plus 1, certainly it will be less than n plus 1 into n plus 1, right? So if I'm doing this n into n plus 1, and if I'm doing this n into n plus 1 into n plus 1, which of the following side will be heavier? Right hand side only, no? So right hand side is it is going to be more, right? Because here you are multiplying n plus 1 into n plus 1, here you are multiplying n into n plus 1. Now what you can do, you can take a root over on both sides. So I will take a root over on both of the sides. So this will be n into n plus 1 here, and this will be root over n plus 1 ka whole square. Okay, and always remember, root over x square is modulus of x. However, here you have this n plus 1. N plus 1 is always positive. So whether you write a modulus or whether you don't write a modulus, nothing would change. So it will be n plus 1 here, and it would be root over n plus 1 here. Root over n into n plus 1, sorry. Root over n into n plus 1. Now divide, take a reciprocal. So you will get 1 upon n plus 1 is less than 1 upon root over n into n plus 1, right? Now since this is divergent, this is something that you know now, this is harmonic series only. The summation 1 upon n plus 1 would be a divergent series. Why? Because we know that summation 1 upon n is divergent. So what is the difference between the two series? If I start from 1 to infinity, I will write 1 plus 1 by 2 plus 1 by 3. Here I will start from 1 by 2 plus 1 by 3 plus 1 by 4. Okay, so even if I remove one term, if it is divergent, it is not going to become convergent after removal of one term. Okay, so understand this particular fact, that since this is divergent, this will be divergent by comparison test. So by comparison test, I can write that if since this is divergent, it implies this is divergent. I hope it is clear. Please take your time. That is why I'm going very slow in this particular lecture, so that you should also understand what am I doing. So, and again I'm saying for such questions may be asked in your JEST exam or TIFR examination. Otherwise, I found that mostly questions are from finding the sum of the series. That also we'll do. That also we'll do. Don't worry. What do you think about this? What do you think about this? Whether it is a convergent series or a divergent series? Just let me know. What do you think about this? Whether it is a convergent series or a divergent series? So if I just think it is 2n into 2n plus 1, right? It is 2n into 2n plus 1. And if I do this way, if I multiply here 2n into 2n, I know that this will be obviously less than this, right? And if I divide it, I will get 1 upon 2n into 2n plus 1 will be less than 1 upon 4n square. And yesterday I taught you in the Riemann zeta function that 1 upon n square is convergent. This is equivalent to what? It is equivalent to zeta 2. And what is zeta 2? I told you by Fourier series also we can find this is equivalent to pi square over 6. So clearly this is convergent. Since this is convergent, it implies this is also convergent. Since this is convergent, it implies this is also convergent. I hope everybody is getting my point. Now try to do this question that I'm giving to you. Try to do this question. What do you think about this question? Summation 1 upon n ln n. What do you think about this particular series? Whether it is a convergent series or a divergent series? Whether it is a convergent series or a divergent series? See, for this question, I taught you yesterday also that you can apply something called as Cauchy's integral test. You can apply something called as Cauchy's integral test. And if you apply Cauchy's integral test, all you have to do is you have to change this particular integration, so change this particular summation into an integration. So instead, I will integrate from 2 to infinity 1 upon x ln x dx. And understand this is a decreasing sequence. That is something that you can that I'm leaving to you as a homework that you can see on your own. Okay. Now you see. Okay, so if I'm saying take this integral, so how would you do this integral? Let ln x be t, 1 upon x dx will be dt. This will be log of log x from 2 to infinity, and clearly at infinity this will become infinitely large. So it is tending towards infinity. This implies, since this integral is divergent, so therefore this series is also divergent. So I'll write that this series is a divergent series. This series is a divergent series. Now what do you think about all these things that I'm telling you right now? Okay. Okay, so what do you think about this series? What do you think about this series? Okay, so if you have to write this particular series, see, uh, if you remember, if you remember, if you remember from your childhood, if I want to write ln of 1 plus x, and if I want to expand it into series, this is equals to x minus of x square by 2 plus x की power 3 by 3 minus x की power 4 by 4, and so on and so forth. And if this is only possible if modulus of x is less than 1. So clearly, if you put n equals to 1, except n equals to 1, if you see, if you place n equals to 2, 3, 4, 5, 6, 7, 8, so this will be 1 by 2, 1 by 3, 1 by 4. So obviously this is going to come in this regime only. So what I can do, I can leave one particular n. Always remember, deletion of a term, that is, if I delete a term from the series, it is not going to, deletion of what, finite number of terms, so it is not going to change the convergence of the series. So if the series is convergent, it will remain convergent. If the series is divergent, it will remain divergent, even if I omit some terms, some finite number of terms. Okay, not infinite number of terms. Finite means any number, let's say 1000 terms, 10,000 terms, 15,000 terms, 10 raised to power 10 terms, even that would also do, but there should be finite terms. So if I am able to remove some finite number of terms and then also assert the divergence or convergence, then it is one and the same thing. So I'll start from n equal to 2 to infinity, the same this thing. Now same this thing can be written as 1 upon n minus 1 upon 2n square, and there are some additional higher order terms. So if n is taken to be very large, all these terms will not contribute. Just think about this term. Just think about this term. This term is divergent. Now since this term is divergent, so this will take all the series towards a diverging series. So this particular series will be a divergent series. Who is spoiling the game? This is spoiling the game. This linear power. Because if this sustains, because we know that 1 upon n is divergent, so it will remain divergent. Whether you add any amount of convergence series to it, it's not going to remove the divergence. So remember this particular series is a divergent series. I hope everybody has got an answer to this. I hope everybody has got an answer to this. Please let me know if in case you have a doubt. So, and if you do not have a doubt, then I will further move ahead. Okay, so what do you think about this series? So today only one thing is clear. I'm going to say quite iteratively what do you think about this series, what do you think about this series, and you have to solve the question. I know it is certainly boring, but this is how you can. Uh, I hope not everybody is getting bored. Actually, this is how the topic is. I cannot help it. Okay, we'll start quantum mechanics. Don't worry. I only want that before starting quantum mechanics, at least you should be thorough with the mathematics part. And daily, I'll be sending you the links of differential equations. Please do them accordingly. Please do them accordingly. What do you think about this series? What do you think about this series? So see, in this particular scenario, when you know there's a power of 1 by 3, there is, so if you remember, there is a formula. A cube minus b cube is what? It is equals to a minus b into a square plus b square plus ab. A cube minus b cube is a minus b into a square plus b square plus ab. If you remember, this is the formula. This is an algebraic identity. So what I'll do, I have this n cube plus 1 raised to power 1 by 3. I have this n. Just remember, this particular n can be written as what? This particular n can be written as n ki power 1 by 3 ka whole cube. Okay. Okay. Now, if I multiply this thing by, let's say this is your a, this is your b. So I'll multiply with n cube plus 1 raised to power 2 by 3 plus n square plus n into n cube plus 1 raised to power 1 by 3 divided by n cube plus 1 divided by 2 by 3 plus n square and plus n into n cube plus 1 divided by 1 by 3. I think this is quite clear. What this will become? The above one, the above. So this is a, this is b, this is a square, this is b square, this is ab. So just think on the numerator what it will be. It will be a cube minus b cube. And what would be a cube minus b cube? A cube will become this, because a is what? A is n cube plus 1 raised to power 1 by 3. And what is b? B is simply n. So if you cube both a cube and b cube and subtract them, then you will get simply this. And if you take this n common out, so you will get n cube, you will get n square, sorry, 1 plus 1 upon n cube 2 by 3. Then you will have again n square, and then again you have n square, because if you take n cube common from here, n cube raised to power 1 by 3 is n into n is n square. So you'll get 1 plus 1 upon n cube raised to power 1 by 3. So in any case, this particular series, this n cube plus 1 ki power 1 by 3 minus n is equal to this. Okay, and then you are having some additions, 1 plus something. So basically denominator is being like, if I compare this with this, so for example, if I just write all these three terms, n square plus some bracket is here plus n square, and then again n square times some 1 plus something is here. So it will be obviously less than 1 upon 3 n square, right? If I don't add these things, so this will be here, your denominator is less, so obviously this overall term would be more, and this particular term, if I compare, so I know, sorry, this is equal to this, and I know that this is convergent. I know that my right hand side is convergent, it implies this is convergent, and if this is convergent, it implies this is also convergent. I hope you've got the point. So convergence of 1 upon 3 n square asserts me the convergence of summation n cube plus 1 ki power 1 by 3 minus n. I hope it is clear. Please let me know if there is a doubt. If there is no doubt, then I'll move further. Okay. I hope nobody is finding it boring. If you're finding it boring, kindly let me know. However, I cannot help you out, but still let me know. Okay, so let us move further. Okay, what do you think about this summation 1 upon n into sine 1 upon n? What do you think about this series? Because actually only for today I'm going to do this. From tomorrow onwards I'm going to fix more on, you can say, uh, Taylor series. Okay, so we'll do Taylor series tomorrow because that is very important. You see oscillations, you see quantum mechanics, you see uh, at many places you'll find Taylor series. So we'll do tomorrow, we'll do Taylor series, but today we have to do this particular thing anyhow. And all of these questions are from standard textbooks only. So don't think that they may not be asked. Probably they may be asked in the exam also. Okay. So kindly do all these things so that things will become easy for us. Just try to do this. What do you think the series would be? Will it be a convergence series? Whether it will be a divergence series? What do you think? Okay, so yesterday, if you remember, I taught you that whenever you are not able to make some assertion regarding series, try to take the absolute value. Try to take the absolute value. That will help you anyhow. So that will help you anyhow. So I'll show you how to go about it, and then you will be able to understand what I am saying. Okay, just give me a minute, and I'll let you know that how to go about it. Okay, so let me do it for you. Okay, so see, whenever you're not able to make some assertion, so always remember, in principle, always remember, your x is always less than sine of x. I mean, this is what you should remember. And here x is not in degrees; this is in real terms. So when in real terms, angle in radians is compared with the sine of x, which is also a real number. Always remember this. This happens to be the case. Okay. Uh, you can write this thing for 0 to pi by 2 where x is positive. Secondly, one can also understand that that only when x tends to 0, especially when you do optics, this is a quite healthier tool to use, that there you actually take this x compared to sin x compared to tangent x. So at many places in optics and in oscillations you find this kind of thing being utilized. So no doubt, when the x tends to 0, sin x is equivalent to almost x. Fine, you can think about it. See, uh, whenever you used to do an experiment in the class till 10th class, what was happening? Your teacher used to say, count the number of oscillations, and there was a pendulum. This was a 10th class experiment. And when you, for just for even fun, when you used to, I'm just thinking, I'm not even telling that this is due to friction. Obviously, there is a friction in the room. Obviously, the damping force would actually act upon, and this is going to get damped also within time. But for first 10 calculations, if the room conditions are uh, quite stable enough, then you can obviously calculate the almost right time of period. But why you used to only take this to a very small angle and not very large angle? The answer to this was, so if you use the torque equation, so you know that this torque equation will be torque is equal to minus of mgl sine of theta, if you remember. And if the restoring torque, if I take it to theta and if I bring it back, so the restoring torque to this particular body m would be minus mgl sine theta. And what would be this? I think this will be half ml square into theta double dot, sorry, half ml square into theta double dot is equal to minus of mgl sine theta. If you remember that what is moment of inertia for a point mass, the moment of inertia for a point mass is simply m into the distance from the point of suspension. So distance from the point of suspension about which it is oscillating, so this is L, so ml square. So what I can say that theta double dot is nothing but it is equals to minus of g by L sine theta. Now, if your theta is very large, which usually students take, basically when we used to have fun around, we used to take a large theta and then we used to send it. The point was it used to even change the plane of its motion. Why it used to change the plane of the motion? Because now no longer you can equate your sine theta to theta. Sine theta can be equated to theta only for the narrower regime of angles, not for very large angles. If you're taking larger angles, then sine theta would remain as it is. Then your term would be theta double dot minus g by L, and then you can write all sort of different terms. Then you can write all sort of different terms. So then your process will become a non-linear process. But overall, for small angle regime, sine theta will be equivalent to theta, and then you replace this sine theta as theta, and then this is a simple harmonic equation, and you can solve things further. Okay, do you understand? So only for the limiting case I can write this way. Otherwise, I cannot do this. So you should understand all these things. I mean, this is very basic. And just for instance, I'm giving you, let's say take theta equal to pi by 6. Let's say take theta equal to pi by 6. It will be around, I think it will be around 3 point, if I just approximate it, so it will be around this. So it will be something greater than 0.5, something greater than 0.5. And what is sine pi by 6? I'm so sorry. What is sine pi by 6? It is again equals to 1 by 2. So it is almost around 0.5 only. So even till angle of 30 degrees or pi by 6, you can say that almost sine theta is equivalent to theta, but still you can see that your theta is slightly greater than sine theta. So always remember, in principle this is true for all x lying between 0 and pi by 2. This will be true only for the limiting case. That for limiting case I can say that sin x is almost equivalent to tangent x and almost equivalent to x. Is that clear or not clear? Now apply the same thing here. I'll take a mod of it. So I'll take a mod of it. What I'll do, I'll take a mod of it. So if I take a mod of it, this will be equals to what? It will be equals to 1 by n mod and sine 1 by n mod. And n is already positive. So it is, if I write this as theta, so this is less than 1 upon n into 1 upon n. Because whether you write mod of sine 1 upon n, are you getting my point? So this will be like 1 upon n into 1 upon n, right? So this is 1 upon n square. Since this is convergent, since 1 upon n square is convergent, it implies this series is absolutely convergent. And I told you yesterday, if a series is absolutely convergent, then this is convergent. If a series is absolutely convergent, then this is convergent. I hope it is clear. Or otherwise, you could also have taken a limit comparison test in which you could have compared this thing. Just compare it by 1 upon n square. Just compare it by 1 upon n square. N tends to infinity, this limit will come out as 1. And certainly this is a non-zero limit. By limit comparison test, since this is convergent, it implies this is convergent. So by limit comparison test, since this 1 upon n square is convergent, it implies summation 1 upon n into sine 1 upon n is also convergent. I hope everybody is getting my point. Please let me know in the comment section if that's not the case. Is that clear? Okay, now a little bit of thing I'm going to assume, and then I'm going to tell you a few things. So I'm writing some, you can say advice, for sum of series questions. So at times you'll find that questions randomly are asked in TFR and JEST or NET, and they will not even give. You will think that why has this come? This was not even in the syllabus. Okay, fine, it was not in the syllabus, but you should be able to manipulate with the sum, right? So I'm going to give you some advice. Don't go into the depth of this. I'm going to give you some advice, or I'm going to give you some, you can say, I should not use the word tips and tricks, but I would give you some idea as to how you should approach a few questions. Okay, so there your standard 12th knowledge will be handy. So if you have a standard 12th knowledge also, then also you can do these questions. So I'll do some questions and I'll make you also do some previous year questions as well. uh, all these questions that I'm right now mentioning have come in the exam. Okay, so just try to find me the sum of this series, and don't panic. I'll solve it for you, but just think about it. And these are all standard 10th question, basically nothing more than that. So if I tell you what will be summation k equals to 1 to infinity k square upon k factorial, how would you go about it? How would you go about it? Okay, and this is today's the last lecture, so don't worry. How would you go about it? So see, if I have to solve this, always remember whenever this k factorial appears, na, think about exponential. I hope everybody is in MSc, so although I'm going to do it tomorrow in a power series, but I hope that everybody knows that this can be expanded in terms of a Taylor series, which is equivalent to 1 plus x square upon 2 factorial plus x cubed by 3 factorial. And if everybody has had a course in complex analysis, then everybody knows that e raised to power z is a entire function, so it converges on the entire plane. And e to power x, obviously, it is also a convergence series. Is that clear? So okay, so if this is the case, just think about this. What would be e to power 1? This would be 1 upon 1 factorial, 1 upon 2 factorial, 1 upon 3 factorial, 1 upon 4 factorial, so on and so forth. Okay, so you can write it as 1 upon 0 factorial also, so that it makes some sense. It makes some sort of, you can get some idea. So now here, this is what you have. So what I'll do, I will try to use this kind of structure. I'm going to use this kind of structure. What I'm going to use, I'm going to use this kind of structure, this factorial kind of things. So what I'll do, I'll take this 1k here, and I'll divide 1k, like I'll take 1k, I'll extract 1k from here, and I'll cut 1k from here. So this will give me k upon k minus 1 factorial. And what you can do, instead of k, what you can do, right, you can write k minus 1 plus 1 divided by k minus 1 factorial. And then you can write summation. Obviously now you can, here you have this, here you can write k equals to 1 to infinity. That is absolutely fine. But once you now you make two pairs out of this. Now you make two, now you make a pair out of this. This is one pair, I mean, you make, and this is another one. So there are two of these things. So what I can write summation. Instead of 1, I will write 2. Why? Because now you will have k minus 2 factorial, and if I start from 1, then 1 minus 2 is minus 1, and minus 1 factorial is not defined. Okay, so if you cut this up, so k minus 1 factorial, now you can understand how can you write k minus 1 factorial. You can write k minus 1 factorial as k minus 1 into k minus 2 and all those things. So I'll write k minus 2 factorial. So k minus 1 factorial can be written as k minus 1 into k minus 2 factorial. K minus 1 gets cancelled, and here you have another term, 1 upon k minus 1 factorial, from k equals to 1 to infinity. Okay, so what do you think this series would be? Just think about this series. This series would be what? Place 2. So this is 1 upon 0 factorial plus 1 upon 1 factorial. So this is simply e. This is also simply e. So your answer should be 2e. I hope this is clear. So the first advice to you is, if at all you have this k factorial coming somehow, think about exponential. Think about exponential. Obviously, you can say that why not think about why not think about sin x, sine and cosine. You can think about sine and cosine only if you have some odd and even terms, because if you correctly remember, the Maclaurin's expansion of cos x contains even terms and the Maclaurin's expansion of sin x contains odd terms. So here you have all sort of, this is this series. I don't know. This is this series. Yeah. So this particular scenario, I mean, this is what has been written. This can be equated to 2e. So question may be asked in your examination, what is the sum of this series? So answer would be 2e. I hope it is clear. Probably I'm not aware of K's exponent, but I hope this is clear. Please let me know in the comment section if anything is anything you're not able to follow. Okay, so I hope everybody is following this stuff. Second suggestion that is very less asked, but at times you may find in exam it is being asked. Second suggestion would be to try to use binomial series also. Try to use binomial expansion also. Try to use binomial expansion as well. So I'll give you a question and then you'll be able to understand why I'm saying this. I'll give you a question. Try to do that question. If you're not able to do, then I'll do it for you. Don't worry. And these are just small, you can say, suggestions from my side. Okay, because the series is a very large topic. Usually, I cover it in around 1 month for maths people. Okay, so that is a very difficult thing for you people. If I take 1 month, then you will be saying, what are you doing? At least even taking 3 classes would feel as if it is more than sufficient. So just do all these things and only whatever I've taught you and whatever questions in further I will give you probably through assignments or somewhere. Do those. Otherwise, you should not pay enough attention to this topic. Uh, However, the next topic that we are going to do, the power series topic, the radius of convergence, that is each year from that you can expect a question. Just try to do this question which I am telling you. Okay, just try to do this question. I think it was asked in TIFR exam. Just let me wait. Just give me a minute. Okay, it's I don't have this question. Okay, I'll give you some other question meanwhile, and then I'll let you know. Okay, try to do two of the questions that I'm giving you right now. Okay, try to do two questions that I'm giving you right now, and then we'll do those questions also. Okay. Now, what do you think about this series? What do you think about this series that I'm going to write? Acha, I'll let you know what I mean by try to use binomial expansion also. I'll let you know. I'll let you know in just a minute or so. But first, try to do this. What do you think about this series? Summation n equals to 1 to infinite n plus 1 raised to power n plus 1 raised to power n divided by n raised to power n by n raised to power 3 by 2 plus n. What do you think? How would this series behave? Will it be a convergence series or a divergence series? Will it be a convergence series or a divergence series? Just think about it. Whether it would be a convergence series or a divergence series, just think about it, and meanwhile I'll give you the question which I wanted to explain. Okay, so in this particular question, it's very easy. Just don't worry about this question. Just try to compare, or try to use the limit comparison test using the series 1 upon n की power 3 by 2. I'll come to this. Don't worry. I'll come to this. Just think about this. Okay, just think about this. So if I'm doing this particular series, which is equal to uh, n plus 1 raised to power n divided by n की power 3 by 2 plus n, then I'm suggesting you try to use the limit comparison test. So n plus 1 raised to power n divided by n n की power 3 by 2 plus n की power 3 by 2 plus n. Try to compare this particular thing using what? Using n की power 3 by 2. Using n की power of 3 by 2. You can do that. So what I'll do, I'll take a comparison by 1 upon n की power 3 by 2. And yesterday, when I was teaching you Riemann zeta function, if you remember, n की power minus p, this is zeta p, and I told you that if p is greater than 1, then this particular series is convergent. So 1 upon n की power 3 by 2 is a convergent series. It is a convergent series. Okay, so if I compare by 1 upon n की power 3 by 2, what I will get? I will get limit n tends to infinity, and if I take this n की power 3 by 2, if I cut this up, so simply I will get n plus 1 divided by n whole raised to power n. Don't forget this is here. Okay, so this is n की power n, and this I can write n tends to infinity 1 plus 1 by n raised to power n. Now if n tends to infinity, this will go towards 0 and this will go towards infinity. If you remember, there was a limit in standard 12 that teachers used to teach you, that if I'm trying to do this, limit x tends to 0, 1 plus lambda x raised to power 1 upon x is e raised to power lambda. It is equals to e raised to power lambda. So if you want to find this limit, this will be e. Certainly this is a non-zero limit. So this particular series and this particular series behave alike. And now since we know summation 1 upon n की power 3 by 2 is convergent, it implies what? It implies this is convergent. It implies this is a convergent series. This is a convergent series. I hope everybody has got the point. Actually, I was searching for a question. I'll just give me a minute. I'll give you that question also. But just tell me if you have any problem with this question. I know I'm going slow, but I want to go slow so that you are able to understand what I'm telling. Okay, I hope it is clear. Just let me see the comment section. Okay, I hope it is clear. Now at times this binomial expansion becomes very handy. Okay, so this binomial expansion becomes very handy means you have to keep okay, so everybody has got the answer. Okay, now just think, when I was saying that binomial expansion is very handy, well, just keep that things in also mind, because at times in exam you may think that okay, probably this may not be asked. I know that binomial expansion is something that you know, but still if you've forgotten it, I'm just trying to revise it for you using a problem. So this particular problem was asked in TFR examination of I think this is 2016. Okay, this is 2016. Okay, and the question said, given the, I'm just writing this question, given the infinite series, yx is equals to 1 plus 3x plus 6x square plus 10x cube dash 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 and all of these things, n plus 1 into n plus 2 divided by 2 x raised to power n. And the question was asked that find the value of yx at 6 by 7. This was what it was asked. So my suggestion for these questions is always keep in mind binomial series. Why? Two reasons. The first reason to it is always remember that binomial series convergent only if mod of x is less than 1. So for example, if I'm writing this 1 plus x raised to power n, and if I want to expand it in binomial expansion, then modulus of x should be less than 1. Is that clear? And clearly you can see here there's this number that is 6 by 7 is obviously less than 1. This number 6 by 7 is obviously less than 1. So they have given you a hint here that we want to evaluate this particular series at 6 by 7. So obviously this is less than 1. Why not why don't you think that binomial expansion why don't you think that binomial expansion can be used? Okay, so there is no I think this is quite obvious that they are actually telling you by the question itself that why not use binomial expansion. Okay, now think about this, just think about this term. Okay, in standard 12th, whenever you used to have linear expansion, okay, teachers used to say that neglect, in fact in much of the classical mechanics you neglect the higher order terms. When it is negligibly small, then you neglect the higher order terms. So what do you think? You concentrate on this term, and you know that if 3x is written, there may be two possibility. Either it would be 1 plus x raised to power 3, or it will be 1 minus of x raised to power minus 3. I mean, these two possibilities can be there. If, like, are you getting my point? Because if there is plus here and minus here, or here minus and here plus, then this will be 1 minus 3, then this will be 1 minus of 3x. However, here what it is written, here it is written 1 plus 3x. So you can clearly see that either this would be the case or this would be the case. I hope it is clear. Please let me know if that is clear. Idea is clear, then we'll do the question, don't worry. Once the idea is clear, then we'll do the question. Okay, now let us expand both of them and see which of the following you'll get. So we'll expand both of them. So let us say I'm expanding this. So what I will get, 1 plus 3x, then you remember now formula. So I hope everybody knows the formula for binomial expansion. 1 plus nx into n minus 1 by 2 factorial x square plus n into n minus 1 into n minus 2 divided by 3 factorial into x cube, so on and so forth. And this is convergent for all modulus of x less than 1. Okay, so if I just if I just take this series, what I'll get, and why did I not take this series? Because see, if I do this n into n minus 1, so after a while this will not be an infinite series. So here you cannot expect an infinite series. So therefore I was interested in the next series. You remember now, 1 plus x ki power cube is what? It is x cube plus 1 plus 3x is 3 times x in, sorry, it is 3 times x plus 3 times x square. So this is not going to be an infinite series. So this was not even the case to even think. But actually I wanted to tell you that whenever such questions come, don't get afraid. I mean, in TFR, even if you do a few questions, then you can clear the exam. Okay, so these questions are freebies, you don't have to leave them up. Okay, so this is 1 plus 3x 6x square plus 10x cube, so on and so forth. So this cannot be an infinite. This cannot be an infinite expansion. You will get an infinite expansion from here. I'm just confirming it. So the second term would be minus 3 into minus 3 into minus 1, that is minus 4. Minus 3 into minus 4 would be plus 12 divided by 2, 6. So this you'll get 6x square, and all the higher order terms you'll get. I'm leaving it to you as an exercise. I hope you'll do it. I hope you'll do it. I think it is quite easy to see that all the higher order terms you can get. This is the general term which has been written, so don't get confused. But overall, I think that this term would be minus 3 into minus 3 minus 1 minus 4. This is 12, and here you will get what? Here you will get, so I'll get you the next term. So minus 3 into minus of 4, then minus of 5 divided by 6, and then you have minus of x ka whole cube. Okay, so clearly you can see this is 3, 4, 5, 6. So 6 gets cancelled here. This will be 2, 10, 10x cube. So next term should be 10x cube. Is it clear? Now what has been asked? It has been asked y of 6 by 7. It has been asked y of 6 by 7. So just place 1 minus of 6 by 7 raised to power 3. So what you will get? You will simply get 1 upon 7 raised to power 3, and the answer should be 343. I think 7 ka cube everyone should remember. So for calculation, I would recommend just remember squares till 1 to 25, and remember cubes till 1 to 15, and remember tables 1 to 25. I mean, this is just a idea that I had in my mind. I used to when I was in 11th standard or 12th standard, I remembered all of these things, like just to increase your speed. Okay, so I hope it is clear. Should I move ahead? Another thing that you can do is probably is use of integration. Use of integration to replace infinite sum of series. So I'm going to give you an idea here. The derivation is a very tricky one, and it involves the knowledge of Riemann integration as a basic. But I can tell you that this is again given in standard 12 board books. But I'm going to give you a direct hint as to how you should be doing this. So now, let us say I give you a question like this. Let us say I give you this kind of question. Summation 1 upon n, limit n tends to infinity, and you have this k equals to 0 to n, and cos of pi k upon 2n. If you have this kind of thing, then what to do? Now this is a very terrific question for you. You will think, okay, how to do it, how not to do it. Now I'll give you a suggestion, and then you will be able to do it. See, the idea behind all these questions is the idea of basic integration. So if you know the idea of basic integration, then you can do all these questions. What I want to say, that if you know the idea of basic integration, then you can do all of these questions. There is no issue about it. Okay, just give me a minute. I'll give you the questions also, more questions also. So if you know the idea of basic integration, then these questions are quite easy for you. So what you have to do, I'll tell you a sort of, you can say trick, or you can say a short way of doing all these things. See, in these questions, always remember, if you have this kind of pattern, that your function that your series can be written as this: 1 upon n and some function of k upon n. And if I'm summing it from k to 1 to, let's say, infinity or whatsoever, and I'm taking n tends to infinity, let's say till n I'm doing it, then what you can do, you can replace this summation by an integration. You can replace this k by n as function f of x. You can replace this 1 upon n as dx, and you can adjust the limits accordingly. Then this particular thing and this particular thing would be equal. Are you getting my point? Is that understandable or not understandable? Please let me know. Once just think about it. I'll if at all you are aware with the basic integration, then I can also derive it. But if you are not aware with basic integration, then it would be better that you should remember this. Is that clear? Please let me know yes or no. Okay, chalo. So just think about this. So now, if I have to solve this in this particular summation, see here you have a pattern in k by n. There is a 1 by n. So what I have to do? I have to replace 1 by n by dx. So I'll replace 1 by n by dx. I'll replace this entire thing by pi by 2x, right? So instead of k by n, I have to write what? X. What this is what I have told you. Instead of the summation, change it to integration and now adjust the limits. See, here you have variable of integration is x, which is equal to what? K upon n. Now see, if k is equal to 0, then x would be 0, so lower limit would be 0. And if k is equal to n, then the upper limit would be n by n, this is equal to 1. So it is simply this particular thing and this particular thing are one and the same thing. Do it. What would be the integration? The integration would be what? 0 to 1 cos pi by 2x, you can write 2 upon pi, and this would be sine of pi upon 2x. Place 1 here. Sine pi by 2 is 1 and sine 0 is 0. So answer should be 2 by pi. I hope it is clear. So not even in dreams can you think that this would be the answer to this particular problem. Not even in dreams you can think that this would be an answer to this particular problem. Are you getting my point? Now try to do another problem that I'm giving you as an exercise, and then we'll conclude the lecture. I hope you're not finding it very boring, but just have a word. I just want to have a word that at least for 7 to 8 days, give some time. Okay, it's not that okay, I'm not going to come to the point. I'm going to come to the point, but only point is that I want to make you a little bit oriented towards my style of teaching. Okay, so my style of teaching would remain this way only. Okay, so I will actually make you a little bit work on mathematics and then we'll do physics, because in competitive examination if I'm going to do each physics terms, then it will be very difficult. So I will go mathematical way of dealing physics, so that will help you in your exam anyway. So try to do this problem. This is easy. Try to do this, and then I'll do another question for you. Okay, try to do this question, and then we'll do a few more, and then we'll finish it off. I'll give you an idea also. What am I doing? I'll give you an idea so that you don't think that I'm teaching you some tips and tricks. I'm not teaching you any tips and tricks. This is something that you should remember from your standard 10th, but 12th. But if you've forgotten, then I'm just teaching you in that way. Just think about it. Just think about this. Okay, let me do it for you. Okay, so what you can do as given above, you can take n common from here. You can take n common from here. So if you take this n common out, what will happen? This will become limit n tends to infinity, and this would be, I think, 1 upon n, and this will be, I think, summation root over 1 minus of k upon n ka whole square, and this is from k equals to 1 to n. Is that clear? Now what I told you, just take k by n as 1, just take k by n as x, and just take 1 by n as dx, and just replace this summation by integration. This is the limit for x, so the lower limit for x would be 1 by n, and where this n is tending towards infinity, so the lower limit would be 0, and the upper limit is n. So upper limit, if you place instead of k, so this will be n by n, and this is simply equals to 1, so this will be equals to 1. I hope this integration you remember. This integration is equal to what? It is equals to x by 2 root over 1 minus of root over 1 minus of x square. If you remember this particular integration, and then plus a square by 2. So instead of a square you will get 1, and this will be sine inverse of x. From where to where? From 0 to 1. Now if you replace 1 here, this would be 0. If you replace 0 here, this would be 0. If you replace 1 here, so sine inverse 1 is what? Pi by 2, and 1 by 2, so answer would be pi by 4. Is that clear? I hope it is clear. The answer would be pi by 4. Strangely. Okay, so three important things that I have told you. One, whenever you are asked to find the sum of the series, one is this infinite sum of series. You can replace it by integration, use of binomial expansion. This actually you get confused at times, and also use at times the Maclaurin's expansion. Maclaurin's means also try to use the Taylor's expansion. If you remember, let's say for example here this is e factor. Now let us do one more question from just exam, and you will be able to understand what I want to say. Let us do one more question from just exam. Okay, let us do one more example from just exam. So, and the question was, I'm writing it here just. I don't know which year it was, but there was a question in just exam. 1 plus 1 by 2 factorial plus 1 by 4 factorial dash 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 this raised to power whole square, and then there was another bracket given to you, and it was I think minus or something. So it was minus of 1 plus 1 by 3 factorial plus 1 by 5 factorial, so on and so forth, and whole square. And it was asked, what is the value of this particular sum of the series? What do you think the value would be? What do you think the value would be? I hope everybody is here. Harish is not here or what? I don't know. Okay, so let me do this question for you. Just think about this particular series. What do you think? What do you think that this particular series would be? See here, if there were alternate negative positive sign, then you can think this as cos series. So cos series, if you are thinking cos series, then you are in the wrong direction. Why? Because in cos, if you write cos in Taylor's expansion about x equal to 0, generally it is called as the Maclaurin's expansion, then 1 minus of x square upon 2 factorial, and then you have this x to the power 4 upon 4 factorial. So clearly this cannot be the case. And from here also you think that probably this is sin x. No, it is not sin x. Sin x happens to be x minus of x cube upon 3 factorial plus x to the power 5 upon 5 factorial. So this cannot be the case also. Sin x cannot be the case here as well. So what I have to do, I will have to somehow see a different alternative. See here only even terms are there. So why not think about this? Think about this. if I add exponential to e to power minus x, what I will get? All the odd terms will get removed. See, all the odd terms will get removed. 1 plus x square upon 2 factorial plus x cube upon 3 factorial plus x to power 4 upon 4 factorial, so on and so forth. And then you have this term exponential of minus of x. This will be 1 minus of x plus x square upon 2 factorial plus minus x cube upon 3 factorial, so on and so forth. Okay, so this will get cancelled, x will get cancelled, and only even terms would survive. And if you divide it by 2, which is equal to what? Which is equal to writing cos hyperbolic x. So cos hyperbolic x would simply be, cos hyperbolic x would be simply 1 plus, sorry, I've got the wrong term. This would be there. This would get cancelled. So 1 plus x square upon 2 factorial plus x cube upon 3 factorial, so on and so forth. And similarly, this particular thing you can also write it as sine hyperbolic. This is something that I'm leaving up to you, because see, here odd terms are surviving, you just subtract it. E to power x minus e to power minus x. This would be equal to what? This will be equal to sine hyperbolic x. Now you know that this would be what? This would be cos hyperbolic 1 ka square, and this would be what? This would be minus sine hyperbolic 1 ka whole square. What it is equal to? It is equal to 1. Okay, so cos hyperbolic x ka square minus sine hyperbolic x ka square is equal to 1. It is plus when it is trigonometry, it is when it is hyperbolic function like cos square theta plus sine square theta equal to 1, and cos hyperbolic x minus sine hyperbolic x equal to 1. And this is how their names are derived. So if you remember, if you think that if you read S.L. Looney, it is a very old book in trigonometry. The trigonometric terms are also called as circular functions. And why they are called as circular function? Because sine theta and cos theta happens to be what? They happen to be the parameters for the circular trajectory. Similarly, cos hyperbolic theta and sine hyperbolic theta, they happen to be lying on the hyperbola only. Hyperbola equation is what? X square minus y square equal to 1. Obviously, some x square by a square minus y square by b square, but does it not look like hyperbola? So hyperbolic trajectory. So that is why you see these are called as hyperbolic function, because they are parameters which satisfy the hyperbolic trajectory. So remember, this would be one answer. This should be an answer. This answer should be 1. I hope everybody is getting this point, whatever I'm trying to explain. I think I'll take one more lecture for this, half of the lecture tomorrow, and then we'll do the remaining one. I think I'll do it on Taylor series. But let me just let me help you with the thing that I told you, that why such thing that I was telling. For example, just by an example I'll tell you, है ना? So just using an example I'll tell you. Example to demonstrate this freedom I can take in physics. In mathematics, for example, is not a proof, okay? But in physics, I can take an example to demonstrate the trick I displayed. The trick I displayed. So nobody thinks that I'm a magician. I'm just telling you the trick that I actually used. So what I told you that whenever you have this kind of thing, whenever you have a function of k by n, and there is some 1 over n also written, and this is summed from some value k equals to something to some n, then this particular thing is changed to integration. How did I come to this particular trick? See, what is integration after all? So if I had to use, I'm giving you an example. And from there you will be able to understand. So let us say that I'm trying to integrate x square. I'm trying to integrate x square from 0 to 1. Let's say from 0 to 1. And let's say I was not aware of integration. What would be the best strategy to do it? I would make certain partitions. And more closer I make the partition, more better approximation to area I would be able to make. Okay, so I'll make more partitions. Now see, if I'm making these partition and if I make a rectangle out of it, and the area of rectangle, if I try to approximate, then what will happen? These are called as upper sums in physics, mathematics. These are called as upper sums. A lower sum, don't go there, but just think about it. If I try to actually approximate this area using the area of the rectangles that I'm making. So this is rectangle, right? So if I make this rectangle, this is height and this is width. So I'm going to over approximate, I'm going to overestimate the area. And if I am joining it from below, this is referred to as lower sum. Then I'm going to underestimate the area. What is the way ahead? That if I was not knowing integration, what scientists initially did, they actually told that why not take these partition as large as possible. Because see, if I am taking less partition, let's say I'm taking less partition, I'm taking 1, 2, 3 and 4, only 4 partition, and then I'm trying to make a rectangle. This would be a rectangle, another rectangle would be this, another rectangle would be this. So this is going to over approximate too much of area. So what is the way ahead? Try to make this partition as close as possible. Try to make this partition as close as possible. So what I'll do, in order to, what is integration after all? Integration after all is area under curve only, na? So this is so something that you know, that what is integration? Integration is nothing but area under this curve. And if I don't know integration, what I'll do? Area under the curve, I will try to break it into small rectangles, and then I'm going to write it. Then I'm going to write the area for it. This is what you used to do in standard 5th. If teacher told you find the area of the leaf, you brought that leaf, you put it in, or you put it on the graph paper, and then you calculated the total number of like total number of full rectangles, total number of full square, half squares, and so on and so forth. This is an exercise given to you at that elementary level, that is in 5th standard. That is what we are doing right now. Okay. So if I take all these things, so what I'm going to do, see here it is. So let us say I'm dividing it in equal manner. Uniform manner. I'm dividing this in equal manner. Okay. So this is 1 and this is 0. I'm dividing it in equal manner in n partitions, and n be as large as possible. Don't forget, this particular thing can be written as, this is area under the curve. It can be written as integration from 0 to 1 f of x dx. But if I don't know integration, then what I'll do, I will try to divide this particular thing into small rectangles. I'll make infinite partitions here, close to infinite partition, that is as large as possible. So what is an area? Area would be this, this and this. I'm showing it exaggerated. So this minus this would be what? 1 by n. Just think about it. If I am dividing it into n partition, what would be the partition? The first would be 0, the second number would be 1 by n, the third number would be 2 by n, this would be 2 by n, this would be 3 by n, this would be 4 by n, dash dash dash, n would be n by n. So these are the partitions. Is that clear? And what is the area of the rectangle? I'm showing a bigger rectangle just to show you. It will not be that big, but I'm just showing this. Just consider this rectangle. What is the area of this rectangle? The area of this rectangle would be base, which is 1 by n, into height. What is height? Height will be the value of function at this particular point. Let's say this is, let us say this is some k by n, and this is some k plus 1 by n. So when these are very much close, whether you write f of k plus 1 by n or f of k by n, they are one and the same thing. Because see, when you are taking n very large, then this is one and the same thing. So basically, this will be equals to what? What would be the value? What would be the value of function at this particular point? This will be function, or what is function here? This will be k by n ka whole square. And you are taking the summation. Okay, and here this function I'll replacing it by x square. Okay, I was taking x square only. So you can understand what I was telling. Replace 1 by n by dx, replace function of k by n by x, or like k by n as function of x. So here k by n is x, so x ka square. Replace summation by integration and adjust the limits accordingly. So lower limit would be n equals to 0 to n equals to n. Sorry, k equal to 0 to k equals to n. I hope I am able to explain this. If you are not getting it, please let me know. So this is the trick. So this is the, you can say, the reason behind that particular